Okay, 5B practice. And this is all about direct proportions. And we use this formula, y over x equals the constant, y equals the constant times x. So we use that with these direct proportions. We need to remember that. Okay, so here we are talking about direct proportions. And if you notice, every question here has to do with direct proportion equation, directly proportional, direct proportion equation. Tell whether it represents a direct proportion, write an equation, direct proportion, directly proportional, write a direct proportion equation. Do you see a pattern there? Do you see that all these problems have to do with things that are directly proportional? And what you should know right now is that direct proportion equation is y over x equals k, the constant, or y equals the constant times x. And you have to know those two formulas to do direct proportion. And we're going to do a lot of it for this chapter 5B, so you'll be fine. You'll be able to do this. Okay, so here we go. So we have y over x equals k. Y divided by x equals k. So this is x divided by y. We're going to go y divided by x. So I'm going to rewrite these ratios here. So y divided by x, y divided by x, y divided by x. And if I divide all those down, 4 divided by 1 is 4, 8 divided by 2 is 4, and 12 divided by 3 is 4, and those would give me the constant. So are these all directly proportional? Yes. What's the constant? 4. So what would the equation be? That looks like this. Y equals the constant, which is 4x. As simple as that. Now, you could also, I look at it like this. I just divide 4 divided by 1, 8 divided by 2, 12 divided by 3. So it would be 4, 4, 4. That's another way to look at it. So let's look at this one. Are these directly proportional? 10 divided by 3. I don't even know anything that goes perfect with 10 divided by 3, so let's just look at this one. 30 divided by 6. I know for a fact that 30 divided by 6 is 5. 70 divided by 9, I don't know that one on the top of my head, but going back to this one, I know that 10 divided by 3 is not 5. So that means these are not all going to be equal, so there's no constant of proportionality, so I'm not going to even work on the rest of that. Okay, so tell whether this equation is a direct proportion equation. Well, this looks like y equals kx. So is this a direct proportion equation? Yes. And what was the constant? 5. This one, I immediately see subtraction. And I know that if there's subtraction or addition involved in an equation, then it's not a direct proportion equation. So none. Okay. As soon as we see this statement, A is directly proportional to B. A is over B, or A divided by B, equals the constant. Okay, instead of y is directly proportional to x, they're using a and b, different variables. No problem, just put them in the equation just as we know how. Okay, so now it says that a is 14 and b is 12. So a is 14, b is 2, and that is going to equal K. 14 divided by 2 is 7 is going to equal K. So now it says write the direct proportion equation. So instead of using y and x, I'm going to use A equals 7B because I'm using A and B instead of y and x. And that's all I had to do there was write the equation. All right, here we go. W is directly proportional to V. So V is going to equal K. And right here it says W is 6 and V is 12. So I'm going to make this a 6 over 12, and that's going to equal K. And I can't do this division easily. That's going to be 6 divided by 12. So I know it's going to be smaller than 1, which is, I'm going to leave it as a fraction basically. So I'm going to reduce that fraction. 6 twelfths is the same as 1/2, which is going to equal K. And you could have a fraction as a constant. So now to write the direct proportion equation, okay, I'm going to use W and K. So I'm going to go W equals 1/2 V. And there we go. There's my equation there. Okay, now we have some words, but never fear, we could figure this out. The amount Brian earns is directly proportional to the number of hours he works. So the amount, which is money, is going to be directly proportional to the hours. And that will give us the K. Y over X. Since they didn't give us any variables here, Y over X equals K. So what was the amount he earned? He made $60.80 for 4 hours. So the amount he earned, $60.80. The number of hours was 4 hours. And if I divide that down, that will give me my K, my constant. And using my calc, I just go $60.80, divide that by 4, and that will give me 15 and 2/10, which if I made that money, $0, $15.20 would be my constant. So what's the constant of proportionality here? Easy enough. $15.20. And the equation, well, they didn't give me any variables to use, so I'm going to stick with y and x, and I just write it out like I know. Y equals $15.20 x. All right, so that puts us through the first page there. Not bad. Got that done. Okay, again, I'm going to look for my direct proportion vocab here because I know that's what this is about, but let's just take a look at it again. For every 3 minutes, 1 is wasted. The amount of wasted is directly proportional to the amount of time that it fits. And write a direct proportion. This one says direct proportion, constant of proportionality, direct proportion, direct proportion, direct proportion, direct proportion. Sean is a mechanic, and the number of cars is directly proportional. See that? Constant of proportionality. Constant, directly proportional. Constant, direct proportion equation. We know how to do this. This is all y over x equals k. We know how to do this. Okay? All right, so let's just kind of revisit that. Here we go. And y over x equals k. Y equals kx. All right, so for every 3 minutes a faucet drips, 1 cup of water is wasted. The amount of water wasted is directly proportional to the time the faucet drips. So the water wasted, WW, water wasted, time that it drips. So I'm using some words to help me set up. Y, X. Okay, so it says 3 minutes is time. Is time going to go on the top or the bottom of this? Time is on the bottom, so I'll put 3 minutes. And that's kind of sloppy, I'm sorry. Let me just make it a little bit bigger here. 3 minutes. And then it says 1 cup of water is wasted. Water wasted goes on top, 1 cup. And that's going to equal the constant. And look at it, it's a fraction. So I'm just going to leave it as a fraction. That's okay. It's a reduced fraction too, so that makes it easy on us. So the constant is just going to be 1/3. And the equation is going to be y and x. So y equals 1/3 x. And they tried to trick us here on this by putting 3/1, thinking that's going to be in order that way. But you have to remember, there's words here that tells us the amount of water wasted is directly proportional to the amount of time that a faucet drips. So you have to make sure you set that up right when you figure this out. Okay, these graphs are easy. A direct proportion has to go through the origin right there. It has to be a straight line. So is that first graph a direct proportion? Yes. Is this a direct proportion? It's a straight line but does not go through 0. So no. Straight line goes through to 0. Yes. Straight line goes to 0. No. Okay, so this one I just do no, no, and no. I don't need to do those. Okay, so now let's go back to this one. What's the constant? Well, when you do the constant of proportionality, you kind of want to find where the what do you call it? I'm going to try to erase this here. Hold on. Okay, that blue line won't erase it for me. You want to find where the lines intersect. And this is at 1 and 1. Okay? And y is at 1 and 0 is at 1. So y is 1. And here it's right here the x-axis is 1. Remember, this is y. This side is y. This is x. So 1/1 is 1. So the constant of proportionality is 1. The equation would be y equals 1x. So that was easy enough. That was an easy one. Okay, let's look at that one. No. Yes, let's look at this one. Okay, so now we want to find where do where's the intersection take place? Well, not at 1, not at 2, at 3, right there is the intersection. Okay, so y here would be 300 over x, which would be at 3. And that, I would just divide that down to get the k, and that would be 150, sorry about that. 150. Okay, and so now y equals 150x. That's all. All right. Let's look at the next one. Sean is a mechanic, and the number of cars he serves is directly proportional to the number of hours he works. So the cars is directly proportional to the hours. Okay, so this is my y and this is my x. So cars are on this side, time is on this side. Okay, so find the constant. Well, I could look at this graph instead of doing everything off the equation right away. And look at that. I got y is 3 and x is 2. The cars and that 2. So 3 divided by 2, 3 cut in half, or 3 divided by 2 is 1.5. And look at that. If I look right here, that intersects at, well, this is 3, and that can't be 2 because that's not 1, so it's between 1 and 3, so that'd be at 1.52, or 1.5. All right, so let's go back over here. So find the constant. 1.5, or 1.5. Either one is the constant, but let's keep it at 1.5. So what does the constant of proportionality represent here? So 1.5, or 1.5, means the number of cars which would be 1.5 every hour. And if you look at that, cars, hours, 1.5, 150 cars in 1 hour. So how many cars does Sean service if he works 8 hours? So we would go, let's use our equation, y equals 1.5x, and x was hours. So we would just go, and we need to do 8. We would go y equals 1.5 times 8. And if I multiply 1.5 times 8, I would get 3.4. So in 8 hours, they would service, wait a minute, what did I do wrong here? It's not 3.4, it's 3 times 4. What am I thinking? Hold on. 1.5 times 8 is 12. So how many cars would he service if he worked 8 hours? 12 cars. He'd make 12 cars, or service 12 cars in 8 hours. Okay, last one. Cheryl works as a hotel maid. The number of hotel rooms she cleans. So the number of rooms she cleans is directly proportional to the number of hours she works. So there's not enough room here. Okay. So the rooms she cleans is directly proportional to the hours. Okay. So find the constant. And it says, okay, so let's look at this. Let's find where it intersects right there. And actually, it also intersects there. But this one doesn't have a number here. So let's go with this one because I have a 5 and a 2. And so it would be 5 over 2. And that would be your constant right there, 5 over 2. All right, so what would be the constant here? 5 over 2. You can leave that as a fraction, or I can turn it to a decimal, which would be 2.5. Okay, what does this mean? So that means that the number of rooms, she would clean 5 rooms in 2 hours. So that's what does that mean? That she would clean 5 rooms, or 2.5, or 2.5 rooms in 1 hour. Sorry. In 1 hour. She would clean 2.5 rooms in 1 hour. And look at the graph, that makes sense. In 1 hour, she's not going to clean 5, she's going to clean half of 5, which would be 2.5. 2.5 rooms in 1 hour. So let's write the direct proportion equation. Y equals 5 over 2x, or you could also write, so this one says rooms T hours. So then I actually would change this into the rooms would equal 5 over 2 T, because it's telling me to use R and T. All right. Explain what the point 6, 5 represents in this, or 15 represents in this situation. Okay. So this means that Cheryl would clean 15 rooms in 6 hours. So that's all you write. Cheryl would clean I'm going to make this bigger. 15 rooms in 6 hours. Okay, so how many rooms does Cheryl clean in 10 hours? Let's look at the graph. Well, this graph doesn't go up to 10 hours, so I'll use the direct proportion equation. So I would say, I would use the direct proportion equation, and I would say the room she cleans is 5 over 2 in 10 hours. So I'm basically going to do multiply that 5 halves by 10. So 5 halves times 10 will give me 25. So 25 rooms in 10 hours. If I wanted to show the fraction times 10 over 1, I could go like this. 50 divided by 2, which would be 25. Okay? All right, moving on. And there it is. There's all the work we've done so far. Okay, here we go again. Let's see if we can find keywords here. Direct proportion. Proportionality, constant, direct proportion. Okay, so let's start working on this one. Use a red. Okay. Okay, so the number of tennis rackets, N, is produced by a manufacturer is directly proportional to the number of hours. All right, so immediately that goes right in order. You see direct proportion. So I'm going to go, I'm going to write this over here. N over H is going to equal K. Okay, so the number of tennis rackets is directly proportional to the number of hours. The production line is operational. Graph the relationship between the number of tennis rackets and hours of production. Use 2 units on the horizontal axis to represent 1 hour and 2 units on the vertical axis to represent 50 tennis balls. Okay, so this side here is my N, This is going to be my hours, so I have to make this on the graph and do what it says. And it says 2 units on the horizontal axis to represent 1 hour. So that means on my graph, I'm going to start here with 0, and I'm going to use 2 units, so that's going to be 1 hour, and this will be 2 hours, and this would be 3 hours, and this would be 4 hours, and this would be 5 hours. Okay, and I'm going to label that. I don't like how this eraser doesn't work. Okay, I'm going to label this hours. Sloppy, sorry. Okay, and then it says 2 units on the vertical axis to represent 50 tennis balls. Okay, so 2 units up here on this one, 1, 2, is going to be 50. 2 more would be 100. 2 more would be 150. Oh, let me make it 150 right here. 2 more would be 200. And 2 more would be 250. Which means, if I was really going to think about it, that this would be 25. This would be 75 if I wanted to do that. But that's not what the directions say. The directions just say go up by 50s. And this side would be number of tennis balls. So you have to label that. Okay. And now let's go back to what it says. Just graph the relationship between that, the number of tennis rackets. Oh, it's not tennis racket balls, it's tennis rackets. And hours of production. Use 2 units on the horizontal axis to represent 1 hour. Okay, did that. And 2 units on the vertical axis to represent 50 tennis balls. I don't know why it says tennis balls, tennis rackets here, and then it says tennis balls here. So we'll have to fix that. This should be tennis rackets. Okay. Now, find the constant. Well, let's graph this information here. It says time 1 hour is 50. So I'm going to go 1 hour is 50. 2 hours is 100, which would be right there. 3 hours is 150. Okay, and 4 hours is 200. Oh, that's nice. So now I have a straight line going through 0. And the constant, well, I'm going to look right here at 1 and 50. So 1 hour will be 50, or 50 rackets in 1 hour. So what would be the constant? Well, what's 50 divided by 1? 50. So the constant would be 50. Let's write our direct proportion equation. Well, I got, did it say use n or anything like that? No. So the constant, well, let's use n and h for hours. So n would equal 50h. Okay, got that. Oh yeah, it does say h and n. I remember doing that. I knew there was something with that. Okay. So now explain what 1 and 50 means. Well, that's easy. We said that in 1 hour, we'd make 50 tennis rackets. So right here, you write, let's just write this way, 50 tennis rackets made in 1 hour. Okay, that was easy. Okay, now find the number of tennis rackets produced in 10 hours. And that is not on my graph. It only goes up to 5 hours. So I'm going to use that equation. Okay, easy enough. So how many tennis rackets can we make in 10 hours, because 10 was the hours there, which would be 500. The number of rackets would be 500. So I'm just going to put rackets made in 10 hours. Okay, that's easy. And guess what? That's it. That's all we had to do for that. Seemed like a lot, but wasn't too bad. Okay, so now these ones have direct variation equation. So write that and solve. Okay, so A varies directly as B. W varies directly as V. You guys know what to do in this. We've been doing this. So we just go right in order. A over B equals K. And it tells us A and B. So 24 over 4 equals K. And if I divide that, that's going to give me 6. So the constant is 6. So now I can write out two equations. A equals 6K. I'm sorry, not K. B. And I'll write the same thing here. A equals 6B. Back to this one. It says find A when B is 7. So A equals 6 times 7. So A will equal, what's 6 times 7? 42. Easy enough. And find B when A is 60. So 60 equals 6B. So divide by 6, divide by 6. B equals 10. Okay. Same thing here, except I have a feeling we're going to get a fraction on this one. Because that's usually what happens. All right, so here we go. 30. Wait. W varies as V, so W varies as V, and that will give me the K. W is 30 divided by 90, and that will equal K. That's a fraction 3/9, which is 1/3. 1/3 is going to equal K. All right, so now I have to write my equations. I'm going to use them for these two problems. So the equation is, I'm going to write them right under here. W equals 1/3 V. W equals 1/3 V. Find W and V is 120. W equals 1/3 of 120. And I'll just write out this equation while I'm at it. W is 25. 1/3. Find V. Okay, back to this one. All I have to do is multiply that together. So, clear. 1/3 times 120. That equals 40. So W equals 40. And this one is divide by 3. So what's the opposite of divide by 3? Multiply by 3. That crosses cancels. So V is left over there. Multiply by this side by 3 on both sides. That's 75. And that's it. We're done with that page. Wow, a lot of work. We are almost there. Whoa, lots of stuff on here, but we could do this. All right, here we go. I see directly proportional. Okay, so Sergio purchased 4 pairs of tennis shoes for $210. Tennis shoes D is directly proportional to tennis shoes number of tennis shoes. So this is dollars, number. He purchased 4 pairs. That will go on the bottom as the number. Dollar amount on top because we labeled it 120. Okay, and if I divide those, that'll give me my K. So 120 divided by 4 is 30. Okay, so find the cost of 1 pair of tennis shoes. The constant, we said 30. $30. That's how much it would cost. $30 for 1 pair. Okay, write an equation. Okay, so D, we're using D, equals 30 n. That was easy, got that done. Now find the value of D when n is 7. Okay, so D equals 30 and n is 7. And 30 times 7 is 210. Final answer. $210. The dollar amount is 210. That's a little sloppy. Okay. That was it. Okay, so Jenna could read 500 words in 2 minutes. Words is directly proportional to length of time, T. So words time equals K. Okay, so she read 502 minutes, so I would go 502 minutes. And 500 divided by 2 is 250. So she'll read, how many would she read in 1 minute? The constant is 250. So that would be it. 250 words. Write an equation with W. W equals 250 T. Done with that. So how many minutes will it take her to read that? The words would be equals 250 T, and it says how many minutes? 1500 words, so 1500 will go under the words. 250 T divided by 250 divided by 250. 1500 divided by 250. 6 minutes. Okay, that was it. Okay, last one. Johnny needs to determine the height of the tree, height of each tree in his tree farm. He knows that the height of the tree, H, is directly proportional to the length, D. So you have to go height and D is going to equal the K. Okay, so now the height of the shadow, the length of the shadow cast by the height is 4 feet. Okay, wait. So the height of the tree, length of shadow. Okay, so this is the height. I gotta be careful here. This is the height of the tree and the distance of the shadow. Okay, so now when I set up this equation, I'm going to go, I gotta read it. The shadow cast by 8-foot tall tree is 4 feet. So the shadow goes on the bottom. So the shadow is a 4 and the height of the tree is 8. And 8 divided by 4 is 2. So the constant is 2. So writing the equation using those same values, h equals 2d, because I'm using h and d in this case. All right, got that. That's all I had to do there. Use your equation to find the height of the tree that casts a shadow 12 feet long. So the height, we don't know the height, and the distance of the shadow is 12, which would be 24 feet high. Oh, that's slap. I am so sorry, but we're almost done. 24 feet tall tree. The tree is 20 feet tall, 24 feet tall. All right, and we are done. Look at all that work, but we got it done. Hopefully that'll help you with understanding these direct proportion equations. We still have one more practice activity to do after this, so the more practice, the better. Hopefully that helped.